Hello viewers, welcome to ECE Sradha Ocean. My name is Suresh Kumar. This is the 11th question from GATE 2019 ECE paper. In this question, infinite length line charge is given and which is arranged along z-axis, and they are asking electric flux through quarter cylinder. So for that, the formula is integral E bar dot dA cap, where E bar is electric field intensity and its formula is rho L by 2 pi epsilon naught R AR cap, where rho L is charge density, epsilon naught is permittivity, R is radius of cylinder, and AR cap is the unit vector. From the question, the charge density is given as Q. So this formula becomes Q by 2 pi epsilon naught R AR cap. Next, dA cap means differential normal surface. There are three kinds of differential normal surfaces, but depending on the parameters we have to select proper differential normal surface. From the diagram, we can say that the phi is varying from 0 to 90 degrees. Why? Because in the case of cylinder, the total angle is 360 degrees. Since we have to consider quarter cylinder only, the angle is varying from 0 to 90 degrees, and the parameter z is varying from 0 to h. Why? Because the height of the structure is h, but we don't know about r. That's why I selected the differential normal surface dA cap as r d phi dz AR cap. So if we substitute these formulas in integral E bar dot dA cap, we can write like this. Here there are two differentiable parameters d phi dz. So the integration I written like this: integral phi 0 to pi by 2 and integral z equal to 0 to h. Here r and r will be cancelled and AR cap dot AR cap becomes 1. So from this, Q by 2 pi epsilon naught is constant, so I written outside and I directly integrated the differentiable parameters d phi and dz. So after integration and substituting the required parameters, finally I got QH by 4 epsilon naught. So from this I can say that option B is the correct answer. Thank you.